Hi everybody. Let's talk about section 8.2, multiplying a polynomial by a monomial. So it's going to look a lot like this distributive property review right here. We're going to have some term, a, on the outside, and we're going to multiply it by a set of parentheses. So my monomial is going to be the number on the outside, my polynomial will be inside the parentheses. So everybody remembers distributive property, right? A times B is AB. A times C is AC, and A times that minus D is a negative AD. So we're going to do the same thing. We're going to multiply polynomials by monomials, only we're going to have to remember some things about our properties of exponents. So first of all, distributive property. Use your property of exponents, like x times x is the x to the second power. When you're all done, combine like terms if you've got them. And I'm going to say this a lot. Write your answer in standard form, which remember is descending power of the degrees. So highest degree first, smallest degree last. All right, let's do some multiplying. Let's do examples 1 and 3. So problem number 1. I've got myself a monomial, 2x. How many terms are inside that parenthesis? So what kind of polynomial is it? Monomial times a trinomial. So let's do some multiplying. So this 2x is going to get multiplied to everything inside the parentheses. So 2x times 4x squared. This is what we just finished in chapter 7, where you'd say, well, I don't know what to do with the numbers, and what do I do with the exponents? Well, 2x times 4x squared gives me an 8x to the third power. Think of it that old-fashioned way. Remember, you add your exponents together. 2x times 3x then should be a 6x to the second, and 2x times that minus 5 will be a negative 10x. It's in descending order or standard form, and there are no like terms to combine, so we are done with that problem. Now let's do one where you've got some like terms to combine. So we'll skip 2, let's jump down to 3. So I've got w's all over the place. Notice I have 2 distributive property problems to do. So I'm going to start off with this 3w, times it only to the end of that exponent, or end of that parenthesis. And then I'm going to multiply this 2, positive 2, to all the things in that other parenthesis. So 3w times 6w. I've got myself an 18w to the second. 3w times that negative or minus 4, I've got a negative 12w. Over that second distributive property, I know that one ends because the parenthesis ends. So now I'm going to start and look and see what else I've got to do. I've got that 2 that has to be distributed to everything inside the parentheses. So 2 times w squared is a positive 2w squared. Remember, just like section 8.1, everything has to have, well, actually, everything has to have a sign in front of it. So it's a positive if there is no sign. 2 times that negative 3w will be a negative 6w. And 2 times that 5 will be plus 10. So we did our distributive property. We used our property of exponents. Now, are there any like terms? Remember, we want to write this to highest exponent to lowest. So I've got myself an 18w to the second plus 2w to the second, because I like to do everything at once. So 18w squared plus 2w squared. Remember, add your coefficients and then keep your exponents the same. I've got a negative 12w and a negative 6w. This is why we did section 8.1 first, so that we would know how to combine these like terms. So negative 12w and negative 6w is negative 18w. This little 10 doesn't have anybody to combine with, but we still are going to stick him on the end of the answer, so plus 10 for our final answer. So 20w squared minus 18w plus 10. Notice it's in descending order, w to the second, then w to the first, and then no w's at all. My lead coefficient is 20. Remember, we talked about that in the last section. So the coefficient in front of the term with the highest degree. So that feels a little bit like old stuff, distributive property, combining like terms, only now we're adding in those exponents on our variables. So we're going to solve some equations along with those. So solving an equation with polynomials. So first thing, if you see parentheses, distribute. That's your big sign, right? We always know we got to get rid of parentheses, so we're going to use a distributive property. Next up, I don't know why that won't go away. There we go. Combine like terms on each side of the equation. I'm going to underline this each right here because we're going to look at it, and we did this earlier this year. We're going to look at each side of the equation separately to see if there are any like terms. Then we go to our old-fashioned inverse operations to finish solving. Some of these problems look intimidating. Don't be scared by them. Some of them look a bit crazy, have squared things in there that we're not really sure how to solve, but it will take care of itself. So we're going to do examples 6 and 8 on these ones and make sure everybody's good to go. So problem number 6. And I keep these extra examples in here so that you can go ahead and do them. My first question for number 6 is, how many distributive property problems do you see total in this equation? Notice it's got an equal sign in it. It's not just an expression. We're going to be able to say at the end of problem number 6 that b is equal to some value. So everybody sees 2 distributive property problems, right? We've got this parenthesis around that 12 plus b. We've got this parenthesis around this negative 4 plus b. So I'm going to start by distributing. So b times 12 is 12b. b times b, hopefully everybody remembers that's b to the second power. Remember, it's just 1 because it's 1 times 1. Don't try to add extra numbers in there. This minus 14 just comes down, and my equal sign comes straight down. In the second side of the equation, what's getting distributed? Is the 2b going to be distributed, or just that plus b over there? So just like the minus 14, this 2b comes straight down, and then only the term that's right in front of the parentheses gets distributed. So b times a negative 4 is a negative 4b, and then b times b is a plus b to the second power. Now do like we did, think way back, look to see if there's like terms on either side of the equation. So when I block out that side, is there anything I can combine with a 12b plus b squared minus 14? I have no like terms, right? So I'm just going to rewrite this. You can change the order if you want to, whatever. I'm just going to leave it until I figure out what I'm going to do with it. Then I'm going to ignore this half for a second, and I'm going to just look at this purple side. Are there any like terms over here that I can take care of? Actually put a piece of paper, an index card, something so that you're blocking things out if you need to. Notice I've got a 2b minus 4b. That's negative 2b. And then that plus b squared just comes straight down. Now I'm ready to start solving this equation. Is anybody intimidated by the b squares? Well, we know inverse operations, we're going to get all the b's to one side of the equation, right? Just like old-fashioned solving, all the numbers to the other. So if I want to take this b squared and get it to the other side of the equation, would you agree that I have to subtract b squared? But if I subtract b squared on the right, I have to subtract b squared on the left. What just happened to all of our b squareds? That was a nice little thing to happen. So now I've got 12b minus 14 equals negative 2b plus nothing, just negative 2b. Oh, this is a good problem. So I know the rule of thumb that we talked about, if in doubt, get all your b's to the left, all your numbers to the right. I'm going to do it that way. If you see a shorter way to do this, feel free to do so. You are a better equation solver than I. So I'm going to add 2b to both sides, because I want to get all my b's over here to the left. So that means I've got 14b minus 14. If these guys cross out, what's left? 2b minus 2b is a big old 0, right? If it were a fraction, we'd use a 1 because we need a placeholder. If we're adding or subtracting, it's a 0. Now let's get our 14 to the other side because numbers go on the right. So if 14b equals 14, I know everybody knows how to finish solving this equation at this point. Divide both sides by 14. So b should be equal to 1. So anytime you've got an equation, you can solve that. So last one, let's do problem number 8. Problem number 8, how many distributive property problems do you see? I've got 2, so let's go ahead and distribute. 2 times 5a is 10a. 2 times that minus 12 is negative or minus 24. Other side of the equation, negative 6 times 2a is negative 12a. Negative 6 times negative 3, watch your sign here, plus 18. And then don't forget to just bring that plus 2 down. Distributive property ends at the end of the parenthesis, but the 2 is still a part of the problem. So if you look at the left-hand side, that red side, are there any like terms to combine? I got nothing. I got a 10a minus 24. If you look at this other side of the equation, are there any like terms to combine? I notice I've got an 18 plus 2. So negative 12a stays by itself, and then plus 20. Now that I've combined like terms on each side, I've just made it simpler. Now I'm going to get all my a's to the left, numbers to the right. So I'm going to start by adding 12a. So I've got a 22a minus 24 equals 20. 2 more steps. What's our next step? Add 24 to both sides. So 22a equals 44. That's convenient. Last step. And what's your solution going to be? Double check my math, but I think 44 divided by 22 is 2. So distributive property combining like terms. That's really what this is all about. Once you get this down, you are good to go. So lesson summary. First thing, what's the trickiest thing to remember in this section? When you're multiplying polynomials, what is it important to remember? Is it signs? Is it distributing? Is it how to do the exponents? Is it multiplying the numbers? What's the trickiest thing to remember? Where to stop doing distributive property? So what is it that you need to tell yourself, I have to remember this? What's the trickiest part? And finally, practice problem. I've got an equation for you to solve. 2 distributive property problems I see, and there will be a pair of like terms over there on the right-hand side, so make sure you're watching those so that you can combine like terms before you start solving. Right? It won't be as bad as it looks. This is just like that example number 6 where you have squares, a to the 2nd power, but they will end up looking better when you finish solving. They'll end up going away, just like our problems for our b's did in that one. Have a great day. We'll see you tomorrow.